Okay, thank you, Tiffany. Welcome everyone today again. We have a great lineup here today. We got some serious firepower in the industry in terms of with James, Jordan, and myself. Hopefully, we can help you out a bit in terms of how we design or how we lay out buildings or some key assumptions in the building code for location of dampers. We'll touch on this a few times through the presentation. But one of the key things is to what we're looking at is we often see dampers provided in the wrong location or actually missed. It can be missed as well. But also, we just want to get to kind of a strategy where it's, hey, these are the minimum code requirements. The code has changed a number of times over the last 5 years, and there's been some nuanced changes that wouldn't always be readily apparent. There is a big cost difference between a fire damper, a combination fire and smoke damper, and in a situation where there's no damper at all, you're going from zero to a cost. We have had, situations after the fact where, we're trying to renovate a building and we walk in and there's a wall that doesn't appear to be a separation. However, it's got a fire and smoke damper in it, and we are unable to move it because no one knows why the original intent is there. And the building department turn around and tell us, hey, we don't know why it's there, so we're just going to leave it there. Or you've any other holes you put in that wall or penetrations, you got to do the same thing. That could have just been a mistake in the first place. Maybe there is something there, but at times it's not communicated. So we're going to talk about that as well, and especially James and Jordan about the effective communication of design intent, and understanding what we're trying to do with a set of drawings in terms of getting that information from the architect right through to the mechanical teams and through electrical for coordination and into actually a constructed building. So, in terms of any building, one of the most basic strategies, and this has been probably the first fire safety strategy of all, is actually compartmentation. It was before the invention of sprinklers, before the invention of fire alarm systems and all the other things we have in buildings now. And the key concept is that it maintains or it limits a fire to a cell or to a unit, to a compartment, to a smaller part of the building. The benefit of that is that when the fire department turn up, when people are egressing, the whole floor, the whole building isn't on fire. You're just dealing with a small portion of the building. It limits the area of the building and allows occupants to egress, and also keeps it to a more manageable size for firefighting. So this is one of the key things that's always been there. You'll see this in sprinkler buildings, unsprinkler buildings, and that it's a key concept of the building code. So anytime we go through an actual fire separation with a fire resistance rating, we have to make sure that those openings are protected, or if they potentially are exempt, depending on how they are arranged. So we talk about the introduction of smoke dampers. This came in around 2022, when they brought in this new change. It had got to do with with higher risk occupancies, such as assembly with higher occupant loads, care treatment, which would have slower egress or maybe limited egress. They might be moving across the floor. And detention, residential occupancy, also slower egress. So most of these were focused around egress provisions for those. There are other areas where you could be required in unsprinkled conditions, and that we'll just touch on those as we go through. So we want to just touch on this. A lot of these changes actually came into the 2012 OBC, but we're talking today about 2024. It's the one we use. There hasn't really been, and when I say the 2012, they actually came in towards the very end of that 22, 23 timeline. They were at the very end of that cycle, but they're now in the 2024. A lot of those were to match up with the National Building Code of Canada. There was a few little coordination items that caused some pretty significant challenges at the start of this, and we'll touch on those as well. But now they seem to have been ironed out for the most part, and we can actually implement the approach to combination fire and smoke dampers as per the intent of the National Building Code, which is what we're trying to coordinate or trying to match up with. So we talked about this. Dampers came into effect 2020. Sorry, I said 2022 earlier. Some key changes around the definition of compartment happened in 2023. I'm going to go to that in a second. And it's the same as the current 2024 OBC. So I see some faces on the call, or some names that this caused some pretty big issues for when we were on pursuits. Public corridors, extended travel distances, all the good stuff we're trying to do when we're trying to bring a building in as efficiently as we can in pursuits. When they changed the original building code to 2012, the Ontario Building Code had its own definition of compartment. The definition of compartment in the Ontario Building Code did not match the National Building Code of Canada. So this might sound like a fairly trivial matter, but it actually caused a lot of problems because the wording in B here under the older code is that the fire compartment means an enclosed space in a building that is separated from all other parts of the building by enclosed construction, so that would be walls or floors, that may be required to have a fire resistance rating. It did not say it had to have a fire resistance rating. It said it may require it. So that meant potentially that 0-hour compartments were put into this as being compartments. So in terms of if you have 0-hour fire separations, such as around public corridors and things like that, this could have triggered the actually provision of dampers in those, which was not necessarily lining up with the National Building Code of Canada. So in 2023, an update was made where the National Building Code definition was brought into the OBC, and it tightened it up a lot in terms of defining this. And a fire compartment means the enclosed space, same thing, except a fire separation having a fire resistance rating. Okay, so for designers, that means our 0 hours are not actually, they don't have a fire resistance rating. They're still a fire separation, but they don't have a fire resistance rating. So that was a key change. So what that meant, it was, in terms of this, say, floor area here, we've got room 1, room 2, say 0 hours. This is just an example. And then we have room 4, which is 1 hour. So under the code now, it very clearly says if that fire separation does not have a fire resistance rating, it is not a compartment. It is the whole compartment. So room 1, 2, and 3 will be combined into one compartment, and the second compartment will be room 4 in this situation, because we have a 1-hour fire resistance rating on the fire separation. So that would trigger the provision for dampers in that. It could potentially be fire and smoke, but it would trigger that is a different compartment, and that became a very fundamental change. And it's what allowed us to tidy up and tighten up the interpretation of these. And I'm sure many building officials were pretty happy when this got addressed. So we're going to talk about a few case scenarios. I'm trying to set the stage here for James and Jordan to actually go into some implementation with some basic code items. I'm not sure, Tiffany, did we set up this poll or not? I don't think we did.
No, you did not set it.
Okay, so no poll for this one. All right, we'll move on. So anyway, we get into don't worry, there's 4 more polls to come. So with this, we have public corridors. Okay, so what is a public corridor? Okay, and a public corridor by definition has to serve more than one suite. That is a very key thing. If you've got you can have many rooms or offices on a floor, but it comes down to suite. So that would be a different tenant, for example. It could be a different bedroom in a hotel. It could be a different condo, but it has to have more than one suite. If you don't have more than one suite, it's a corridor used by the public. Okay. I'm not sure why they couldn't have come up with some better term for this back in the day, and clearly, internal corridor or something like that, but it is what it is. So corridor used by the public. And where we use corridors by the public is when we want to extend travel distance. So if we have a very large footprint, such as, say, when we're doing conversions of industrial buildings into data centers, where we're now chopping them up, we often use this strategy. Or we have very large spaces that are being turned into offices. We have to use corridors used by the public that get us past 45 meters so that we can measure from the door. So this is what I'm talking about, measuring from the door. So if we had a situation where we were measuring from the door, this corridor would trigger a rating so that we could allow us to do that. It could be a 0 hour if it's sprinklered. It could be 45 minutes if it's not sprinklered, depending on the arrangement. But this is what would happen inside a building. So this does play into how we interpret the building code. So when we talk about this, it's not always easy to communicate this on a set of drawings, but there are some examples later on of how this can be communicated more effectively, so that we can keep the design intent for all the team and convey it with as the project, the future for maintenance and things like that. So, this is the introduction. This is the requirement for fire and smoke dampers. We're not going to drill too much into the actual wording here, but there are some key items. The first one is you require a damper and a fire separation. And then this is the actual requirement. There's a waiver coming up. There are some key things. We talked about separation of a public corridor. That's 2 suites, not one. 1 suite is a corridor used by the public. However, under B, if you were using that same corridor to extend the travel distance, you might trigger one. Then there's the kind of more at-risk occupancies such as care, treatment, detention, residential, and then the last one is protection of a barrier-free path of travel. That would only be for unsprinkler buildings, hospital, care homes, and retirement homes. We're not going to touch so much on D today. We're going to keep it more about the offices and that, but that is what it is. So this is the fire damper waiver. As I said, we're not going to go too much into fire dampers. We're really looking at the cost associated with bringing in the smoke dampers. So we're not going to touch on this one for too long. This is a waiver. I think this has always kind of been here. It's got to do with commercial cooking and different arrangements of ducts and things like that. So this is the key one we talk about. This is the smoke damper waiver. And this is one that was, when we go back to our definition of compartment, was causing a lot of issues because there's the first one up, serves commercial cooking. That's all, that's totally fine. It's very difficult to put a duct in there. You got all the grease and stuff. It's going to be a problem. The next one is where in which all inlet and outlet openings serve not more than 1 fire compartment. So this is a permission where we can actually get rid of the dampers off a corridor if they all stay in the 1 compartment. So that means they can't punch anything that has a fire resistance rating. They can only stay in that compartment. And that is an example, you might see that in the school, single-story schools. You might see it on an office floor, things like that. And then we have the other examples for the protection of barrier-free paths of travel in that, and then we have hospitals and that for the compartments. But as I said, we're mainly focusing on the offices. So this is another one for smoke damper waiver. We're not going to go too far into this one, but this has always been there, and this is how you arrange the duct to allow you to waive it. A very small cross-sectional area of 0.13, and it can be used for certain types of units. So this is a example of a corridor used by the public. So this is within 1 suite. We have measured from the doors. So this would allow us to do 45 meters from the doors to the exit stairs, and we could have another 45 meters, so we could be up to 90 meters if we rate this corridor. Separation of suites. So we go back to this. We look at these. This actually is a corridor. We'll go into that example next. But if you have a multi-suite floor, so you've got a whole bunch of offices on the same floor, business and personal service occupancies do not need a fire separation between them. There is no requirement for it. It is specifically exempt under 33111. In addition, this actually is not contingent on sprinklering. It is just not required. It's other things in the building code, like rating of public corridors and corridors used by the public, is contingent on if the building is sprinklered and travel distance. This one is not. It is straight out not required for business and personal service. So we get into this where we show a multi-tenant floor. This is it. We have more than 1 suite, so this should be public corridor. Travel is measured in the suite and it's sprinklered. So then we end up with no fire dampers required because we have a public corridor, but there's 0 hour on the public corridor and there's 0 hour on the suites. So because of how it's arranged and it's a business occupancy, so there's no compartments, and the way the travel distance is arranged, we don't actually trigger a fire resistance rating on the corridor. So we're allowed to waive the fire resistance rating on the corridor. So that means we don't have to put in the smoke dampers. However, if we take the exact same floor, same public corridor, and it's unsprinkled, this is where we don't get to do this. Now, the units still don't need a fire separation between them because they're business occupancies. but we do have to rate the corridor because it's non-sprinkler. So that when we go into separation of public corridors, so this one, if we ran the ductwork down through the middle of it and we did have to put a fire resistance on the corridor in non-sprinkler condition, the same corridor would actually have to put in the fire and smoke dampers on it. I think that is same thing again. Public corridor, travel distance measured with the door, it's the same. The unsprinkler condition would trigger it to be required. Okay, James, I believe are you up first?
Yeah.
So if you want to go ahead and share your screen, you can take over. So yeah, if there's any questions, anyone, please just pop them in the chat. We'll get to them, or sorry, pop them in the Q&A, and we'll get to them at the end.
Okay. Can you see my screen there, Jack?
Yeah, I can see it. Yeah.
Good to go. Okay. Thanks for kicking things off and getting us started. For those who don't know, James McEwen, I'm a director at BPA. BPA might sound new to some people, but we formerly were the Mitchell Partnership, or TMP, and have recently joined with BPA. And Jordan, if you want to introduce yourself as well.
Thanks, James. Yep, my name's Jordan Hodder, Senior Associate at BPA and mechanical engineer.
All right. So, I think Jack's talked a lot about fire ratings and kind of why this matters. Tiffany, did we have that first poll ready to go as well for ours, or no?
Yeah. Are you ready for me to launch it?
Yeah, go for it.
All right, there it goes, folks.
So, one of the reasons why we think this matters is because it often comes up at bad times on projects. We wanted to get some people's feedback on that. Okay, results coming in.
Based on the results so far, it looks like it is occasionally sitting at around 58% of everyone joining today.
Yeah. So, I mean, it is something that we deal with on almost every project. The rules are really complicated and convoluted, and so it's easy to mix things up. And for us, there's a lot of kind of circular references that we deal with in the code. So we're traveling back and forth between different scenarios. The code changes that Jack mentioned have also kind of made things more complicated, and then future clarifications have changed it. So over the last few years, there's been a lot of change that we've had to keep up with on it. That's made it a little challenging to keep track of. So let's launch the second poll as well. So one of the issues that we deal with is just the cost. So let's say for the equivalent size fire damper that might cost $1,500 to install it, what do people think the equivalent size smoke damper might cost once it's installed?
From the feedback we have received so far, everyone's sitting at around $4,000. There are about 42% of the people joining that are sitting at $4,000.
Okay. So roughly maybe double to kind of 3 times is what people are thinking. That I think, we think the right answer is that it's at the 8,000 plus, because when we're dealing with a fire damper, that's really just one trade that you're dealing with. They're installing the fire damper, they're connecting it to the rest of the ductwork. When we have to do a smoke damper or a combination fire smoke damper, you all of a sudden have to start including a lot more trades in that coordination. So, the smoke damper itself needs power. So you need your electrician to get in there and wire it up. The smoke detector device needs to be connected to the fire alarm system. There's maybe a little bit of gray area there, depending on some of your interpretations, but sort of our reading of the code and best practice would be that those duct smoke detectors do need to be connected to the CACF. We think it's good practice as well to connect the smoke damper itself to the CACF, just for ongoing monitoring, maintenance, and testing of the devices. The whole system then needs to be programmed, and it needs to be tested for the CAN ULC testing of systems. So there's a lot more that has to go into the installation of those devices. And so they just get more expensive, and quite a bit more expensive than a simple fire damper. So, the two approaches are, can we remove the rating? And if not, how can we remove the smoke damper? It's really to extract some cost savings from the projects. And I know everybody's here is seeing their projects get more and more expensive. So any opportunities for savings is something that we should be going after. So what we think is the best way to go about this is looking at the exclusions that we can use about either where are they actually required, and to also look at how can we use all of the exclusion rules that are out there for us to be able to remove them. And the new rules that we have are a lot more complicated than they used to be previously. And it's not just dependent on, is there a rating, yes or no? There's a lot more that goes into it in terms of what is the occupancy of the space? Is it a public corridor? Does it have a barrier-free path of travel? Is it a specific type of egress door? And so that is information that's hard for us to extract just looking at a simple plans set of drawings, right? We don't necessarily know what all the occupancy types are on the drawings. We don't necessarily know, is this corridor a public corridor, yes or no? So architects are probably often getting questions from their mechanical engineers to say, is this a public corridor? Does it need to be a public corridor? Is the public corridor rated? For us to determine if these are actually required. And so our kind of thought process is that the best way for that information to be communicated to us and to use as a tool is the fire life safety drawings. It's kind of the most obvious place for that to go, to not only show on those plans what the ratings of the building are, but to indicate where we do have public corridors, be it with notes or maybe some kind of hatching pattern on the background of the drawings. Same thing for the barrier-free path of travel, where those might exist. And then also labeling on those plans what the subsidiary occupancies of the spaces might be to help us look at those requirements to see, is it an assembly occupancy space type, yes or no? Or is it maybe an industrial F3 type occupancy? And so we don't have those same requirements. The other thing that we do when we can is to try and use Revit as a tool. So most of us are doing new projects in Revit, and we can actually use the parameters that are in Revit to help us with our coordination. So every wall has the fire rating parameter to it. And when we link in your models, we can extract that information. We can create graphic overrides. We can turn walls red, green, blue, so that we're seeing where all those rated walls are. And in some ways, it's a bit of a return to the AutoCAD days. I know when I started still working in AutoCAD, the architectural backgrounds that we would receive would often have P lines for where the fire ratings were. So they were really obvious in the backgrounds where those ratings were. I think we've lost that a little bit in the transition to Revit, but we don't necessarily have to. So just a quick example here where we applied a hatch pattern to our black and white drawings. So the exhaust air shaft there, it's rated, it gets the pattern. We can very clearly see where on our drawings the ratings exist. And then the other walls that are beside it for those fan rooms, they don't have any of that hatching pattern because they don't have ratings to them. And now I'm gonna throw it over to Jordan, who's gonna talk a little bit more about this.
Thanks, James. Yep. So in this section, we're going to talk about when less is more and trying to eliminate dampers through smart design. So just want to pull back the curtain a little bit on how we assess and our drawings from a mechanical perspective. So we assume that we only need smoke dampers or combined fire smoke dampers really in kind of 4 instances. That's the starting point. So what Jack and James alluded to these conditions, it's all based on the OBC 3.187. So once again, when a duct penetrates a fire separation, we're looking for public corridors, egress doors, serves an assembly care and treatment, detention or resi occupancy. And then lastly, for barrier-free path of travel, there might be a couple other nuances in cases where we would require a smoke damper, but generally speaking, that's our starting point. And then how do we actually navigate the rules? So as Jack alluded to, there's lots of different opportunities where we can waive the requirement for smoke dampers or fire dampers even to reduce the cost of the project. One thing that we've found is that the code itself, it's 1,200 pages, and there's a lot of references in one section to another section to another section. So you kind of have to follow the breadcrumbs once you kind of really do a deep dive in some of these complex situations. So we've kind of created an in-house flow chart to really help us kind of capture those nuances and created a decision tree. And for us, it kind of provided some clarity on where we actually need to provide smoke dampers. And it's kind of given us a bit of a decision path to removing them. So smoke dampers, this is a similar section to what Jack showed before, where we can waive smoke dampers. So there's a few common ones. The fire compartment one is a big one. Residential corridor pressurization, we'll have an example later in the slides. Janitor's closets, there's lots of discussion around janitor's closets in our office at least. Lab exhaust subducts is an opportunity to remove smoke dampers. Passing over a fire separation with actually serving space. And also public corridors. I think there's a lot of opportunity where the public corridor might not even be rated in the first place, and that's an easy way to remove a smoke damper. Fire dampers, I think, are a little bit more clear. There's a few obvious ones on the mechanical side, kitchen, laundry, lab exhaust, subducts, some confusing ones with janitor's closets. But once again, this is the process that we go through in our flow chart to see where can we actually remove them, where do we actually require them. Next slide. Real world examples. Okay, so we'll start off with a couple fun photos. Unplanned access panels. We've gotten to the design process where, you get the question, where do we need access panels? And anytime we need a smoke damper, fire damper, we need to get access to them. So here's a picture. You have a fire separation on the left, a bunch of ducts penetrating through that fire separation, need a bunch of access panels. Doesn't look too great. Here's one where you have a corridor, ducts crossing through left and right, need to have access to all the smoke dampers that are in the ceiling space. This actually looks pretty clean. But I know as an engineer, when I walk into a room, the first thing I do is look up, and you see access panels up there. So if we can clean those up, I think that's better for everyone involved.
Yeah, one thing I'll just jump in on is, the reason the access panels are required is because those devices need to be tested and maintained annually. So, it's not just there if you need to go reset the device. It technically, building operations teams are supposed to be testing these devices annually. So regular access is required for them.
Yep. No, thanks for that, James. That's a good point. And bad coordination. So it can result in a lot of back and forth. This is a doctored title block sheet, but you can see there's an opportunity where you have to do a lot of reissue for permit, and nobody likes that. It delays schedule, has cost. And you can start getting into some really detailed conversation with plans examiners. It can get really, really convoluted and tricky. So we want to try to eliminate them at the get-go. So good coordination, what is that? So what can an architect provide to help? So James mentioned a number of these. We're going to show some examples and some following slides. But fire life safety drawings, labeled separations, public corridors, having those hatched would be awesome for our teams. Having the room occupancies, so the subsidiary room occupancy, not the building principal occupancy, but the subsidiary room occupancy. There's a lot of opportunity for us to go through our decision tree to eliminate dampers if we know that information. And then it's very important that everything's reviewed by a code consultant and get their input as well. Jack and his team do a great job. And there's some opportunities where we can get rid of the rating as a starting point, and that's the best way to start getting rid of dampers. Here's an example courtesy of Super Cool. So you can see a fire separation notes, all the spaces, corresponding OBC references, and on the right have a fire separation legend with all of your fire resistance ratings. This is great, color coded, really helpful for us. And here's a plan drawing of what that looks like on plan. Once again, we're seeing all of the subsidiary occupancies right on the plan, all of the fire ratings as well. It's really helpful and clear to us to go through our process. Next slide. Oh, sorry. If you want to go back one, this is time for a poll. If we poll number 3, I believe, Tiffany. Perfect. Thank you. So on your projects, how often are public corridors and occupancy types clearly identified on life safety drawings? Curious what the responses here are. How are we looking, Tiffany?
Just waiting for a couple of more people to submit. Come on, guys. The more numbers we have, the more accurate our response. Come on, let's see. Let's see. Right now, it's looking like we're sitting at 31% of people in attendance are saying sometimes. 22 are saying always, 24 is usually, and 25 is almost never.
Okay, so kind of all over the place. Okay. Yeah, I think just seeing it more and more would be beneficial for projects in the long run. Next slide, James. Okay, janitor's closets. So we're going to get into the next couple of slides some more specific examples. So in this case here, we have a janitor's closet. It's that kind of tiny room in between the elevators there on the left. It has a 0-hour rating around it. On the right-hand side, we have a code reference for do we need to have a smoke damper or not as we cross that separation. We have our exhaust duct in purple there. So the answer is we kind of need to know some more information. So if you want to go to the next slide. So on the left-hand side, if the adjacent space is in assembly occupancy, so group A2 goes back to one of the 4 requirements. It is required, smoke dampers needed. It serves a assembly occupancy. On the right-hand side, though, if it's an F3 space and it's a mechanical room, for instance, you don't need a smoke damper because you're not serving a F3 space. Next slide. So this is if we assume now that the adjacent space is a public corridor, once again, that's one of the 4 requirements, and we would require a smoke damper. Now unless, this is the big unless, there's some caveats to this. So if you have an exhaust duct that serves the janitor's closet with a fan and it goes right to the outside without crossing another fire separation, it only serves the one space, it only serves one fire compartment, you don't need to have a smoke damper. If you have a single floor and you have your washroom exhaust, janitor's exhaust to a exhaust system, discharges out of the building, doesn't go up and down through other fire separations in the building. Once again, it only serves one fire compartment. Jack had that great sketch kind of showing the floor of the 1, 2, 3, and 4 spaces. So a 0-hour rating is not a fire compartment. So this is another a nuance where we can eliminate the requirement for smoke dampers. Next slide. This one's probably a bit more well-known, but janitor's closets and fire dampers. If your floor area is sprinklered, you don't need to have a fire resistance rating, so it's 0 hours, so you don't need to have your fire damper. Next slide. Residential public corridors. So a handful of years ago, this was a bit of a struggle until there was an amendment to the code. So if we describe the system, so on the right-hand side, we would make a bare unit. It serves the residential corridors on a number of floors in a building. We have branch takeoffs, providing makeup for all the suites. And the question is, do we need to have a smoke damper on all those branch connections onto all the floors? The answer is you don't need to have smoke dampers. That unit is used to limit smoke movement. So in a fire, it remains in operation. Very unlikely smoke's going to enter back into that duct system, up the shaft, into another floor. So because it stays on in a fire, you don't need to have a smoke damper. Next slide. And I'll let you tackle this one, James.
Yeah, sure. So the example on the screen, this is really just something I sketched up quickly as an illustrative example. So say an office building with a central core and a multi-tenant kind of corridor situation. There's several scenarios that can pop up depending on, is it a public corridor or not? Is it rated or not? How many suites are on the floor? Travel distances. There's not necessarily a one-size-fits-all solution because our famous answer is always that it depends. But there's a couple of typical scenarios that we see pop up whenever we get into these multi-tenant floor scenarios. So number one is where we have the main supply duct coming out of the mechanical room. If it crosses right over that public corridor, if it does have a 0-hour rating, say it's even a system that serves multiple fire compartments, as long as it doesn't supply into that public corridor, like it has no openings into it, then you can use the exclusion that lets us waive it for that scenario. Item 2 is there where, let's say you do have to cross into it and you do have openings into that corridor space. Under the previous iteration of the code, we would have to put a smoke damper in there because it was treating a 0-hour rated wall as creating a separate fire compartment. But under the current definition, we don't have to do that anymore. And so this is something that we expect, until maybe all the industry catches up to that change in definition. I'm sure plans examiners are going to say, you need to put a smoke damper here. But we're fairly confident that the way the code reads right now, it wouldn't be required in that scenario. Again, for item 3 there, hopefully we can use some of the exclusions that exist. If your travel distances aren't exceeded, if the building's sprinklered, then we don't need the rating anyways. And so you don't even need to worry about smoke dampers in that scenario, as there's no rating involved. One of the kind of key things to watch out for is return air ducts in these public corridor scenarios, because you can't actually use a public corridor as a return air plenum. So if you do have return systems, they need to be extended out over those corridors, which can sometimes cause coordination issues. And the other item that Jack mentioned earlier is separation between suites. Just taking a really close look at that. Our interpretation is that they're usually not required. If they do go in, it can start to create lots of challenges with the existing duct systems that are in place. If you had to go in and cut in a fire damper or cut in a smoke damper, every time a new demising wall was added, these ducts would get chopped up like Swiss cheese over and over again. So kind of we're hoping the takeaway here is that the rules are a little bit complicated. There's some nuance to it, but there's actually a lot of scenarios where smoke dampers aren't required if you look at things closely. And for us, the best way to kind of get that information and review it, we think, is by using the fire life safety diagram drawings that are on projects, or just, if it's a small project, you don't really have fire life safety diagrams or you don't need them, then indicating what the occupancy of the space might be or where public corridors might be right on the plans, so that we can see where all those things are to help us make the right choice. And really the ultimate goal is to simplify construction, to reduce costs, and to make things simple on site. And particularly with the smoke dampers in existing buildings, which are undergoing renovation, if you do have to start adding, 1 or 2 more devices to the fire alarm system in terms of the duct smoke detectors, it's maybe not so bad. But if you have to start adding 10, 20, hundreds of new devices to an existing system, that existing system may not be able to handle new devices, which can then start to trigger much larger infrastructure upgrades to buildings. And with that, I think we'll leave it there and start looking at some of the questions.
Yes, does anyone have any questions? I don't see any in the chat right now in the Q&A. Anything coming in there if you want to pop one into the Q&A or into the ideally Q&A, so we can keep them all in one location if you have any questions. I saw one of the comments in the chat, James, on City of Toronto doesn't accept color drawings. So that's still okay. It still needs to be conveyed to the team. I think it's still okay to do in the color coding, or any suggestions around that?
I mean, in terms of our official submissions, yeah, we still print those in black and white. So like for us, we can't use color to convey information. We can certainly use it internally though for coordination, right? And that's our general approach. Like for us at BPA, all of our drawings we try to do in color just because it makes things easier when you're looking at a set of plans. But when we do official prints and submissions, then we'll usually do those in black and white. And it's not just the City of Toronto. There are other jurisdictions that want black and white drawings as well.
Okay, I don't see any other. Oh, here we have a question. We got a bunch. Okay. So yeah, you will get the slides. Does the removal of a smoke damper from ductwork penetrating a public corridor for corridor pressurization of a residential still apply to a medium low-rise building where there is no CACF room or is only for taller buildings? This is the one about the pressurization of the corridor. That's a high-rise requirement, so it would only come in on high-rise buildings. So it wouldn't. It could be on a medium, depending on the height of the building and what you would consider. It's 6 stories typically is what we'd above that we'd tip into high-rise, and we trigger the requirement for the corridors to be protected. And then we have done alternative solutions to address other corridor situations. I don't know, James, if you want to comment, or Jordan, on that?
Sorry, what was the question?
Just on on lower buildings, if we don't require pressurization of the corridor on removal of dampers there, if we don't have an airflow, we've done it as an alternative solution to add the airflow back in.
Yeah,
but
yeah.
It's an alternative solution. Yeah,
yeah, I would agree with that.
Question.
There was a question.
Right, yeah.
Can we receive the slide?
Yep.
Or the flow chart? Sorry, but that's an internal thing for us. It's also a work in progress, so it's not something I'd feel comfortable sort of putting out there.
So
one of the questions was, if the building has a smoke control system, can we do without duct-mounted smoke detectors adjacent to the CFSDs? So this was actually a kind of a big conversation I had this week, is do duct smoke detectors have to be connected to the CACF? The interpretation that we have and that our electrical team has is that they do. When you look at the CSA standards on installation of fire alarm systems, they list a duct smoke detector as initiating device, which needs to be connected to the CACF system. So it seems somewhat black and white from that perspective. I've spoken to a lot of electrical engineers about it. Some think there's some gray area, if it's not a detector and it's a sensor, but that's getting a little into the weeds and deep into the nuance. So ultimately, it's the design team's call what they do. Certainly for new construction, I think the right way would be to connect it to the fire alarm system. When you're in a renovation and you don't have the ability to connect to an existing CACF panel, it can get a little bit more complicated, which is why we focus on removing the requirement from the smoke for the smoke damper altogether, so that you don't need to have that duct smoke detector connected to the damper, and simplifies your life quite a bit. One of the questions was, do you need fire caulking at the damper sleeve? I'm pretty sure you do, but you'd need to just look at the installation requirements for the damper, but I'm pretty sure you do. That's right in the installation details. So if you go take a look at a nailer or a Ruskin installation instructions for one of those dampers, you should see that requirement there.
So I'll just take this one from Brady. For a single tenant space, non-office, where are you using corridor used by the public to extend travel distance? We've done this in a whole bunch of data centers, where we've converted very large industrial buildings into data centers. We cannot meet they're originally designed around the 60-meter exiting around the perimeter. So we have gone ahead and divvied up the interior of the building to put in public corridors used by the public to extend get ourselves up to 90 meters, 45 meters within the room, and then 45 meters from the door of the room. So that would be a situation there where we would be using corridors used by the public to extend the travel distance. Depending on how they are arranged, if we're still a 0-hour corridor, we don't trigger smoke dampers. If we're a rated corridor, which we have been in the past, depending on the classification, we would be up on it would trigger the fire dampers and smoke dampers to be installed, because we are extending the travel distance and we're a rated corridor system. That's Brady's one. So what if there are openings in a 0-hour fire separation? So that's a good question. You still can punch through with the what's called the doors obviously are on closers, the walls is the full height, but you are allowed to go through it with ductwork. It doesn't say you have to have the damper in that separation. Because it's not a fire compartment.
You want to take the next one as well?
Which one is that?
From Bernardo.
So more than one suite served by a public order must be a fire compartment, right? And not always. So it depends on the occupancy. So business occupancies can be exempted. Most other, so if you'd say, just say with 2 restaurants, they would be fire separated from each other. Because of the suite-to-suite fire separation, the wording the code says adjoining suites. Depending on how it's arranged, the corridor may or may not need the rating if it's sprinklered or unsprinkled. So if you need a rated fire resistance rated corridor system, yes, you would have to put in dampers and fire dampers. But if you didn't, if you were able to, for example, if you met lower travel distances or depending on sprinklering, you may not have to make the corridor an actual fire compartment. And it also depends on the rating. Like for example, if you take an office building, the code waives the requirement for the office to have a separation between each other. It technically doesn't even say you have to have a wall between tenants. There's nothing, the code says nothing about it. And if you meet all your travel distances, you don't even have to put a 0-hour fire separation on the corridors. You literally could have, a whole bunch of tenants in the same space without walls between them if you wanted to get very literal on the code. It's not what we do, but the code doesn't actually say you have to put a separation in the business occupancy. You don't have to rate the corridor when it's sprinklered. So there are situations where the code has fairly low levels of performance for separations. Stephen wants to know that we will make the presentation available. It'll also go on YouTube if you want to share it with anyone else.
So Dan's question, what if there's a transfer air opening in a 0-hour rated fire separation? So not a public corridor. So it would depend on the occupancy of the space. So again, if it was a 0-hour rated, if it's an assembly occupancy, then you need to look at, is it a separate fire compartment or not? But in the case where, let's say in the case where you do need a smoke damper on a transfer air opening, the key thing to watch out for there is just that you need to have duct smoke detectors on both sides of the transfer air duct.
Just on other occupancies on the Group Cs, that Group C corridor would require a fire rating. So you would require a fire rating on that. So then you would trigger the fire and smoke dampers unless you're doing one of the other exemptions for the high-rise buildings we mentioned, but they would be required.
So Stephen Liu's question, if a duct is running through multiple suites but does not serve the suites themselves due to ceiling height restrictions in other areas, do we require fire smoke dampers at every crossing penetration? This was an issue for long-term care in hospitals. If I think in the case of, yeah, hard to say without looking at a drawing and seeing it, I guess is the short answer. But for long-term care and hospitals, that's one of the major occupancies that requires smoke dampers at penetrations. If it truly passed through the spaces without serving the spaces, then I would say there's probably grounds to remove the smoke dampers. But if the separations between the spaces have a fire resistance rating, you would need the fire damper, right? So you need to be able to stop the fire from spreading through the ductwork into the adjacent spaces. But if there's no way for smoke to get into the ductwork, it can't spread to other spaces. So answer is it probably depends a little bit, but there's could be grounds for taking them out. Yeah.
Claire, just on Claire F there, in it for B1 cell blocks and large police station, would SD or CFD, CF, so smoke dampers or combination fire smoke dampers be required at the fire compartment or only at its perimeter? It depends on how you fire separate the cells. I know the ones we've worked on, we have just done the actual whole perimeter. We have not individually divided the cells. They're not fire separations, so those ones we have. So yeah, obviously you could look at it, but in general, it's on that compartment. It's the separation between contained use and the rest of the police station. And just Karen, yes, we have. There is some work being done in BC. BC Housing did an alternative solution guide on elimination of dampers. We actually have just put it in on a project in Manitoba. We're waiting to hear back from the city of Winnipeg on that. But it's following what the work that was done in BC for certain arrangements of dampers and exhaust and the ERVs and things like that. But there is work happening there to try and bring down some of the construction cost. It's a very interesting article actually, or that whole there's a whole report on it about the reduction in cost and how much it costs on the projects and different things. So that's one we are doing, and as I said, we're waiting on feedback. If there's any questions for anyone, feel free to shoot us an email. You can send it through to us there, and even if you don't have one of our emails, we'll send it through to Jordan and James if it's applicable. Some of these things we can't always just give you an answer off we can't shoot from the hip. Live code consulting isn't always the best idea. There's often other context around it that we like to see. So yeah, if you have any bigger questions, feel free to reach out to us.
Yeah, thanks a lot to Jack and the Vortex team for organizing this. This was great.
Yeah, and great. Thanks, Jordan. Thanks, James. And great to see everyone. Lots of friendly faces, lots of good, our usual clients. So it's great to see everyone.
Thanks, all. Great attendance today.
Thanks, everyone.